Okay, Stargazer here. Okay, you can check out the Stargazer. This is a very useful package for you to generate the tables of the regression. So I think I don't know which package it belongs to, but Stargazer. I think you still have to install the Stargazer package. Okay. Anyway, so this is to help you to become more familiar with the output here. Okay, so this is important. So we have some examples down here, and this is about the logistic regression and the k nearest neighbors. And the more interesting thing is that we can use this to predict to forecast the stock price movement. Okay, so you can see down below, we can just okay, the first one is to use logistic regression to predict the stock price. Okay, stock price, whether stock price will go up or go down based on some observations. Okay, of course, you can also define your indicators. Okay, maybe in this case, we are using the okay, the author here are using some indicators. Okay, and some indicators, for example, lag of 5 days, simple moving average, lag 5 days, exponential moving average, and the MACD, okay, and the lag of log returns, and lag of RSI, okay, because these indicators are flexible and customized, and it strongly depend on your preference. So this is just example. You can include as many indicators as you like, and based on this, you can include this in your model. So based on this data, then we can run our logistic regression here. Okay, so down here below, okay, you can see here. Okay, so we are using the logistic regression, and first of all, we have to split out data into training data set and the test data set. So that's based on 70 versus 30 days data split. Okay, and then we can run our logistic regression here. Okay, so you can see down here. It's here. Sorry, let me see. Okay, so now you can see the method here. Okay, the method here is using GRN. The family is binomial. Okay, so we are using this model. Okay, to run. We are using these codings to generate the logistic regression. Okay, and based on this, then we can calculate the accuracy of the prediction. Okay, so this is based on the logistic regression. Okay, and based on this, we can also generate the confusion matrix. And okay, so this is about the confusion matrix. And then another approach is KN. Okay, so KN should be the easiest one because we are calculating the distance of the K nearest neighbor algorithm. So this is quite straightforward. Okay. Okay, so this is a very useful case for you to study by applying the logistic regression K nearest neighbors for classification. Okay, similarly, if you want to get more uh, topics based on these approaches, maybe you can just use Google. For example, just like I mentioned, the LDA, okay, because this is a linear. Discriminant analysis, this is what we just discussed, and in stock price prediction. Okay, if you are interested in these topics, then you can check out these papers because actually there are some papers being generated in the literature. Okay, so for example, like stock market movement prediction using LDA. Okay, so this is just one paper discussing this issue, but actually there are so many similar papers out there, okay, using this approach. So what I mean is that if you're interested in these topics, maybe you can just find one paper and then you can try to treat this as a potential topics in your graduation thesis, because next semester you're gonna have a project course. Okay, then you have to complete your thesis. Okay, and I strongly suggest you to find an interesting issue. But of course, you may choose one more closer to the financial theories, just like what we are just like what we are studying right now. For example, in your portfolio analysis course, we will also introduce some traditional models. For example, like single index model, Fama-French model, three-factor models, etc., to construct your portfolio. But similarly, in this course, I will also introduce some machine learning models. Okay, we call this as machine learning models because sometimes we don't have a real financial theory to support these machine learning models. Okay, we don't have a financial theory. For example, like we don't have a financial theory like factor models or CAPM capital asset pricing model. Okay, to select the most potential stocks from the markets. However, on the other hand, in this course, we just use some machine learning models to select stocks, okay, from the market. So you can also try to think about which topics is more interesting to you, because nowadays we do see a lot of machine learning models working in the financial studies. Okay, but we don't see any real results, okay, saying that okay, machine learning models are definitely better than the traditional financial models. Okay, we don't have a very theoretical support for this. So machine learning models, even is even they are very new, okay, very advanced in some ways, but my view is that okay, maybe in terms of this ability in prediction accuracy, they may not be better, okay, than the traditional financial theory models, theoretical models. Okay, so this is just for your reference. Okay. Okay, I'm not saying that okay, which one is better than the other, but what I mean is that you should check out you should check out these papers. Okay, you can check out these papers and see if they are really outperforming the traditional financial models. So for example, in this case, stock market movement prediction using LDA online learning models, we can see that, okay, we do see some conclusions here. Okay, you can see here we compare LDA online to ANN, KNN decision tree in both batch and online learning scheme. We found that LDA online provided the best performance, okay, the highest performance measured on Google, Amazon, Apple, Facebook, stocks, are much better, okay? Okay, so this is just for reference, but this is just one of the many papers, and you can also see there are many other papers here, okay? So for example, this is another one. Oh, it's in 2015. Detection of stock price manipulation using discriminant analysis. Let me find a new one here. Okay, so this is another topic about the comparison of machine learning methods for predicting the direction of US stock market on the basis of volatility indexes. Okay, never mind. This is just for your reference. So let's come back to the slides here. Okay, I just want to I just want to give you some references about the application of machine learning in the market. Okay, now we are talking about the generalized linear models. Okay, so what does that mean is that we are talking about more complicated response variable y, because in this case, response variable y is either quantitative or qualitative. Okay. However, we may sometimes be faced with situations in which y is neither qualitative or quantitative. So this will be a little bit more complicated, okay? But I'm not here to discuss this issue deeply, because this is out of our, this is not what we are ready to dig into, because this model involves more complicated issues. So I'm not here to discuss this issue. I just need you to know that, okay, we do have a model called generalized linear model, okay? And that means the Y response is neither quantitative nor qualitative. Okay, down here are some examples here. I just skip this. Okay, before we dig into the Poisson regression, I want to introduce another model called the categorical model. Okay, so just give me a minute. Okay, so this is the, I think I have posted this link on the trunk class. Oh, okay. I have posted a link on your trunk class so you can reference this link in chapter 8. Actually, in your regression model, this is the model we will encounter quite a lot. We call this as the categorical dependent variables. Okay, so because in your logistic regression or in your explanatory variables, we usually have dummy variables. Okay, dummy variables will only have 0 and 1, okay, or yes or no. However, sometimes our explanatory variables maybe we will have many different types, okay, not just limited to 0 and 1, yes or no, okay. So in this case, we will have categorical variables, but in the categorical variables may belong to the dependent variables, but some cases categorical variables will belong to the independent variables or explanatory variables. So I want to show you the categorical variables here. Just a minute. Okay, so if you check the categorical variables here, you can find many resources on the internet. But basically, it's not that difficult because we can just treat the categorical variables as dummy variables because we have so many different levels. And then the first step is to convert the data into factor data, and then you can run the normal regression function. Okay, so it's very straightforward, and you can run normal regression function, and then you can generate the output. Okay, as usual. So nothing is difficult. Okay, it's very straightforward. So there are other examples down here. So I just want to let you know that, okay, we have categorical variables here because in your study in the future, you may have chances, you may have many chances to use the categorical variables in your regression. Okay, so this is just for your reference. Okay, down here is the Poisson regression. This actually is transforming the response variables into probability based on the counts. Okay, so you can see that suppose that basically we have a Poisson distribution, a Poisson function, okay, to calculate the probability of the counts. So you can see the Poisson distribution is typically used to model counts. That is the natural sort choice of number of reasons, including the fact of the counts like Poisson distribution. Based on this, maybe we like to run this kind of regression. Okay, so we have what we can call this as Poisson regression. So based on this, then we can use this formula to represent the Poisson function. We call this as Poisson regression. Okay. So in this case, we can fit the Poisson regression model to data set bike share. Okay. So the only difference is that we can specify the family. Okay, to be equal to Poisson. Okay, so everything is the same. We specify the response variables, and then we specify the family equal to Poisson, and then we can generate the output here. Okay. So the problem is about the interpretation. Okay. So that means an increase in xj by 1 unit is associated with the change of expected of y equals to lambda by a factor of exponential beta j. Okay. So this is one thing about this is about the interpretation. Other things about the mean variance relationship. Okay. So we can implicitly assume that the mean bike usage in a given hour equals to the variance of bike usage during that hour. Okay, so this is about the data structure. Okay. And another thing is that non-negative fitted values, there are no negative predictions using the Poisson regression. Okay, because we are calculating the probability of the counts. Okay. So this is about the Poisson regression. Just for your reference, okay, but we will not, I will not give you the questions about the Poisson regression, okay. So I just need you to be familiar with the problems like LDA, okay, and KAN, okay, and some other QDA, okay, quadratic discriminant analysis. Okay, so I just need you to become familiar with those approaches. I think that would be more important. Okay, so I will skip this KN here. Okay, down here down here is about the implementation of the KNR. So you can see here we can use some codings available here just to run the KAN. Okay, but usually we will use the close folding. Okay, close validation folding in our test data set. So this is a very this is a traditional way to do our testing or model fitting here. Okay, so let's just take a break first, and then we will finish this part finally.